Hello, I'm Dr. Z, and I volunteer with the Children's Science Center. This is one of their do-it-yourself series videos, and in this video we're going to be discussing the basics of magnets. You know, magnets are everywhere in our daily life. In our homes, they're in washers and dryers, televisions, computers, refrigerators, cell phones, cars. They're just about everywhere. So they're a very important part of our daily lives. Most magnets today are what they call man-made, or they're made by a process which can develop magnets of varying strengths. Usually a magnet is made up of a metal, and there are only a very few metals that are actually capable of becoming magnetic or are attracted by magnets. When you put those metals together, that's something called an alloy, and many of the magnets that we are familiar with and work with today are these man-made synthetic alloys. They come in many shapes. This is a familiar one, the kind of horseshoe-shaped one. This is a bar magnet. Here's one that's kind of shaped like a donut. And this one is in a cylindrical shape. And actually these are two magnets. And while we're at it, you may remember that we say that in every magnet there's a north pole and a south pole. And that's because scientists have learned that the magnetic force within a magnet comes out of the top of the north pole and goes around the magnet and goes back in and to the south pole. So even though we can't see it, there's a cloud of invisible magnetic lines of force that come out of the magnet and back into the magnet. And you know that if the north and the south of a magnet come together, they attract each other like this. But if you bring together either the north or the north, or the south and the south, there's a repulsion and they fight each other. And this is because of the nature of these magnetic lines of force that are coming out of and back into the magnet. And we'll go back to get back to that in a minute. Now, like I said, there aren't many metals that are capable of being made into magnets or that are attracted to magnets. This is a bar magnet, and as you can see, things like paper and rubber from a rubber band, and this is a piece of wood. It's not attracted. This is a piece of copper wire. Copper, even though it is a metal, is not attracted. Aluminum, even though aluminum is a metal, it's not attracted. But here's a paper clip, and paper clips have iron metals in them, and they are definitely attracted, as you can see. And this is an iron nail, and iron nails are also very much attracted to magnets. Okay. So, what is the nature of this strange magnetic force that is coming out of the magnet and back into the bottom of the magnet? It's all around the magnet. What is a force? I guess we better begin there. And a force is some sort of interaction that can change the motion of an object. So there are three things here. There's an interaction, there's a change that's taking place, and then there's a motion, a change of motion. For example, here's an iron ball. If I interact with this by touching it with my finger, I am changing the motion. I'm changing the speed and the direction at which that ball is rolling. So that's an example of a direct force by touching it, actually. So there's a direct action or interaction. There are other kinds of interactions that are not so direct or that they're at a distance that can't be seen. And the magnetic force is one of them. For example, this ball that I was just shoving around is made of iron, and we know iron is attracted to magnets. And I have my bar magnet here, and you can see that I can start affecting the motion of that ball by coming near to it, and actually I don't even have to touch it. I can actually affect the motion at a distance. Whoops, almost dropped it. So magnetic force is one of the forces that can act at a distance. And that's again because of these invisible magnetic lines of force that are coming out of the magnet and back in. This reminds me that, do you know what the biggest magnet is that we live on? It's the Earth, right? The Earth is a big magnet. And that's because at the center of our Earth, there's this rotating core of liquid metal. And that's creating a magnetic field. And you know, we talk about the North Pole of the Earth and the South Pole of the Earth, just like we talk about the North Pole of a magnet and the South Pole. So the Earth actually has a tremendous magnetic field all around it. And if it weren't for that magnetic field, we'd be in a lot of trouble, because a lot of the things that come from space, especially particles that could be very harmful to life, are deflected or bounced away because of our magnetic field. Okay, so is it possible for us to kind of see more of this magnetic field? And these are some things you can do at home. You can buy yourselves some magnets on the internet or at Amazon. This is a type of magnet called neodymium. And it's a man-made magnet and one of the strongest. And so this is something that you can buy on Amazon, and it's fun to experiment with. But again, I want you to be careful with these. They're quite strong. That's why I'm wearing gloves, because you can, when you're trying to work and get these magnets apart, I actually have 3 magnets here, and it's really hard to get them apart. And sometimes when you do, you get your fingers pinched. So be careful with them. Okay, so you can also buy these donut-shaped magnets online or at Amazon. And a fun thing to do with them is that the magnet has, again, the donut shape has a north pole and a south pole. So if you put the donut magnet kind of on a stick, and then you put another one where the poles are reversed, or actually these are lined up north and south, but if I reverse them, you can see that there's actually a levitation taking place. That second donut magnet is actually floating on top of the first. And that's again because of these magnetic lines of force. In this case, they're fighting against each other and keeping them suspended. And there actually are trains that ride on magnetic lines of force. So that's something you can play around with at home. This is another thing you can do. I actually, bought this again at Amazon, and it's a cube filled with oil, and also in that cube are lots and lots of little, what we call iron filings. It's as if you took a piece of nail and cut it down into very, very small pieces, and you suspended it in that oil. As you can see, there's a hole in my cube so that I can put my magnet in there. And if you put your magnet in there and you just watch it, you're going to see that those iron filings are going to start lining up now with the magnet inside. And you notice that most of the particles are either going at the top or at the bottom of the magnet. And that's because the magnetic field is even stronger at the top and the bottom of the magnet. So that's something you can play around with. If you don't want to buy one of these, what you can do is get yourself some iron filings. So those are pretty easy to find at a hardware store, or again, you can buy them on Amazon or online, and put them in a jar like this. And you can see, you can hear them playing around. Now, if I take a strong magnet, like one of my neodymium ones that I put in the bottom here, and I shake those iron filings around, you can see how interesting effect the magnet has on those particles. It's almost like they're creating crystals or stalactites that you see in a cave sometime. And that's again because of the magnetic field being created by these magnets are lining up all those little particles. If I take the magnet off, again we go back to iron filings. Pretty neat, huh? These are just some things you can do at home. If you get yourself some magnets, test the strength of magnets by seeing how many paper clips they can pick up. And as a little final demonstration, this is a really neat one. As you can see here, I have a bottle filled with what looks like a very dark liquid, okay? It's like black water. This is called a ferrofluid, and it has those particles of iron suspended in this special liquid. If I take a magnet and I put it at the bottom, can you see that? That what was all liquid before has now become a solid. You can see it hanging there. Almost looks like a porcupine. And that's because, again, these magnetic lines of force are interacting with those iron particles suspended in this fluid, and it really turning it into what looks like a solid. If I turn it around again and take the magnet off, it goes right back to a fluid. That's called a ferrofluid. So there are lots of fun things you can do with magnets, and I would encourage you to look around and maybe see if you can find some magnets and do some experimenting. Again, be careful. Sometimes they can pinch your fingers. And the next time we get together, I would like to talk about a special kind of magnet called an electromagnet. Okay, thanks for tuning in, and I hope you love science as much as I do. Talk to you soon.